morning, sir. Today I'll be presenting about the light investigation 12.2 titled Reflection of Pins in a Plane Mirror. The objective of this experiment is to investigate the characteristics of the image formed in a plane mirror. The apparatus used in this experiment are a plane mirror, softboard, 3 pins, and a graph paper. Here I'm cutting out the softboard since my plane mirror is very small compared to the softboard. Here I made my own graph paper since the graph paper was too small for the softboard. The first procedure is to set up the apparatus. So first, put the graph paper on top of the softboard. Then, place the pins anywhere in the graph paper. Then place the plane mirror in the middle of the softboard, like this. The second procedure is to observe the images formed from the plane mirror. The third procedure is to find the distance d1 and d2 by counting the number of squares between one of the pins and the mirror surface and between its image and the mirror surface, then compare the distances. Here, as you can see, the green pin is 1 box away from the mirror, and the same goes for the image, which means they both equally have the same distance. Procedure 4 is to repeat procedure 3 again with the other 2 pins. Here, as you can see, the white pin is 2 boxes away from the mirror, and the same goes for its image. And here you can also see that the red pin is also 2 boxes away from the mirror, and the same goes for its image. This is the diagram of the experiment. In the picture, 2 rays come out from point A, reflecting the mirror to the observer's eye. The reflected rays are drawn using the law of reflection. The dashed lines are from point B, which is the formed image of point A. The image height of the distance from B to B is the same as the object height of the distance from A to A. Forming images of all points of the object, we get an upright image of the object behind the mirror. 2 light rays coming out from point A on an object are reflected by a flat mirror into the eye of an observer. When we extend these reflected rays backward, they come from point B, that is behind the mirror, which is where the virtual image is located. Repeating this process for a point A gives the image point B. The image height is thus the same as the object height. The image is upright, and the object distance d1 is the same as the image distance d2. The reflected rays look as if the image is actually behind the mirror, but in reality, the reflected rays come from the points on the mirror where they are reflected. The image behind the mirror is called a virtual image because it cannot be projected onto a screen, since when we go behind the mirror the image won't be there. However, in front of the mirror, the reflected rays are as if they are from behind the mirror. So in conclusion, the image of each pin is the same size as the pin. The image of each pin is upright, and the image of the pin is virtual, since the image and object are the same size from the same distance from the plane mirror, and the image is upright. The distance of the image from the plane mirror D1 is equal to the distance of the object from the plane mirror D2. Taking the figure formed by the pins as an object, its image is laterally inverted. That will be all for the light investigation, reflection of pins in the plane mirror. Thank you, sir, for listening.